Hello everyone. The title of this video is Solve Quadratic Equations of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a not being 0, by completing the square. Now every exercise I'm doing in this video is taken directly from a free online textbook at openstacks.org. It is their Intermediate Algebra 2nd edition text. I am in section 9.2, titled Solve Quadratic Equations by Completing the Square. And I'm under the heading Solve Quadratic Equations of the form ax squared plus bx plus c equals 0 by completing the square. Now I'm only going to be doing the even numbered exercises. So exercise 100, 102, 104, up to 110. You may notice that the odd numbered exercises, have links on them. And if you click on those, you'll be taken to the solutions for those problems. So I'm doing the ones that don't have solutions in the text. Also, I would request that whenever I bring up a new question, pause the video, right? Try to work on it yourself first before watching me do it, right? Because if you're just watching me do it and not practicing yourself, chances are you're not learning all that much. And one other thing I want to point out too is that I'll be putting timestamps for each of the questions I do in the description of this video. So example 1's timestamp will be for number 100, example 2 for number 102, example 3 for number 104, and so on. So you can hopefully you can bounce around to different questions a little faster. Great. Alright, so first question is exercise 100, which I have written out. Let's see example 1, number 100, exercise 100 in the text. Yeah, and all we're asked to do is solve the equation, right? Solve by completing the square. Alright, so I'm assuming that you know how to complete this square. And I had a previous video up also about solving certain quadratic equations by completing the square. Alright, so I'm just going to write the steps out over here, what steps I'm performing. And it's going to be the same steps every single time. Right? And you can perform these steps for any quadratic equation. So the first step is to get x squared, or whatever the variable is, it's not always x, but get x squared plus bx on its own side. Now notice that's the quadratic term and the linear term. And the quadratic term must have a coefficient of 1. 1x squared. And that's really easy to fix if it's not 1. Right? If the quadratic coefficient is not 1, just divide by whatever number it is, and then it'll become 1, right? Because any number divided by itself is 1. So I get the quadratic term and the linear term on its own side and then some number on the other side. And make sure the coefficient of the quadratic term is 1. Then you complete the square on the binomial, the x squared plus bx, which again I'm assuming we know how to do from previous videos. If you don't know how to complete the square, please look it up. And then you should be able to solve using the square root property, which again I'm going to assume you know based on previous videos or previous sections in the text that I'm taking these problems from. Solve using the square root property. Alright, which I'll label SRP when I use it. And that should be it. Alright, and of course check your solutions, right? But that should be automatic. You should always be thinking about checking your solutions to an equation when you're done. Alright. So for number 1, we have 2x squared minus 14x plus 12 equals 0. I want to get the quadratic term and the linear term on their own side. So the 2x squared, right, that's the quadratic term, the squared term, and the negative 14x. I want to get those two terms on their own side. So the first thing I'm going to do is subtract the 12. So we have 2x squared minus 14x equals, negative 12, right? 0 minus 12. Now I'm close to ready. Right? We have the quadratic term and linear term on their own side. Fantastic. But the coefficient of the quadratic term is not 1. It is 2. I want it to be 1 in order to complete the square. So that's simple enough. Just divide by 2. Right? Divide by 2, or whatever it is. In the next question it'll be 5. But divide by that coefficient, divide everything. And don't forget it's an equation, right? What you do to one side you have to do to the other. So I divide everything by 2. So we have, x squared minus 7x, right? 14 divided by 2. Now I have what I want on the left side here. I have the quadratic term with a coefficient of 1 and the linear term. So now I'll be able to complete the square. So I'm going to leave a little space for the number we're going to add to complete the square. And then, the other side again, I'm dividing by 2. Negative 12 divided by 2 is negative 6. Right. Now, we complete the square. So hopefully you remember how to do that. And I'll describe it. Remember, you take the linear coefficient, which is negative 7, cut it in half. Negative 7 divided by 2 is, negative 7 halves. Then square that number. Right? Negative 7 halves squared is 49 fourths. And this is what gets added to this binomial to create a perfect square trinomial. Now, don't forget it's an equation. When I add the 49 fourths to complete the square on the left side, you must also add 49 fourths to the right side. Right? You can't just add something to one side and not the other. You got to keep it balanced. Now the whole reason for this is so we get a perfect square trinomial. This x squared minus 7x plus 49 fourths is equivalent to a binomial squared. And that binomial is the variable, which is x, and then plus whatever half that linear coefficient was, so minus 7 halves. And you can check this. Take x minus 7 halves and square it. So take x minus 7 halves and multiply it by x minus 7 halves again, and you'll get x squared minus 7x plus 49 fourths. Alright, now the other side, I need to get a common denominator, right? You can't just add numbers together without a common denominator. Negative 6 is negative 24 fourths. Alright, that's negative 6. And then we have plus 49 fourths. And putting those together, the denominator, the common denominator stays, remember? you just add the numerators. Now negative 24 plus 49 is positive 25. All right, so x minus 7 halves squared equals 25 fourths. And now I have a scenario where I can use this square root property, where you have something squared equal to a number. So by the square root property, by SRP, or I'll just write SRP for the future, x minus 7 halves is either the positive square root of 25 fourths. Right, now the square root of 25 fourths would be 5 halves. Or this x minus 7 halves, right, the expression being squared, is negative 5 halves. Because either one of these, 5 halves or negative 5 halves, when you square it, would give me 25 fourths. All right, and then we solve each of these by adding 7 halves. So first x equals, 5 halves plus 7 halves would be 12 halves, that'd be 6. So x equals 6, or here negative 5 halves plus 7 halves would be 2 halves, positive 2 halves, which would be 1. So x equals 6 or x equals 1. And then don't forget to check your solutions, and you always check back in the original equation. All right, and I'll do these out loud. These are some nice integers, so this won't be so bad. If I plug in 6 for x, 6 squared is 36, 2 times 36 is 72, and then 14 times 6 is 84. 72 minus 84 is negative 12, plus 12 would be 0. So 6 makes it true. 6 does work. And then 1, you basically would just have 2 minus 14 is negative 12, plus 12 is 0. That also works. So the solutions of this equation are positive 6 and positive 1. Don't forget to check your solutions at the end. And always back in the original equation, right? The way it was originally given to you. That makes it more so you know if you have a valid solution or not. Wonderful. Yeah. And I'm going to be following again. I'm going to be following these same steps every single time. Get that quadratic term and linear term by itself on their own side. Make sure the coefficient on the quadratic term is 1. Then you can complete the square, and then you can apply the square root property and solve, and then check your solutions. Right? Same thing every time. All right, great. Number 2. This is exercise 102 from the text. Now, it's already starting off kind of how I want. The quadratic term and the linear term are on their own side. You got a number on the other side, but the lead coefficient, the coefficient of the quadratic term, is not 1. So that's easy enough to fix, right? Just divide both sides by 5. All right. So I'm going to divide both sides by 5, and that'll give me x squared plus 4x, right? Don't forget to do it to every term. And now that the coefficient of x squared is 1, and I've got my quadratic term and the linear term on their own side, I can complete the square. So I'm going to leave a little space. I like to leave a little space for that number I'm going to be adding to complete the square. And then the other side, 15 divided by 5 is 3. All right, so now comes the completion of the square, right? You take half the linear coefficient. Half of 4 is 2. And then square that, right? 2 squared is 4. So I'm adding 4 to both sides. Don't forget to add it to both sides. The left side becomes a perfect square trinomial. Right? So x squared plus 4x plus 4. I can write this as a binomial squared, where the binomial is the variable x plus whatever half that linear coefficient was, right? So the quantity x plus 2 squared. And you can check that. X plus 2 squared, x plus 2 times x plus 2 would be x squared plus 4x plus 4 equals, and then over here 3 plus 4 is 7. And now I can apply the square root property, right? Something squared equals a number. So this something, right, so by the SRP, this something, this x plus 2, can either be the square root of 7, right, or the opposite of that, right, or negative square root of 7. And then in both of these, I'm just subtracting 2 to solve, right? So x equals negative 2 plus the square root of 7, or x equals negative 2 minus the square root of 7. Now you could also combine these, right, because they're just conjugates. You could say x equals negative 2 and then plus or minus the square root of 7. Both are equally valid. You can keep them separate or put them together with the plus or minus symbol. But now I want to check. Alright, now I want to check. Now you could check it by, by hand. Take negative 2 plus the square root of 7 and square it, and then distribute 5, and then distribute the 20 over it, and then see if you get 15 equals 15. Now that'll take a little bit. So sometimes I like to check with a calculator. Alright, so I've got a TI-84 Plus emulator that you've seen in other videos of mine. And what I'm going to do is I'm going to put in that number, that solution, negative 2 plus the square root of 7. Alright, and then I'm going to store this. I'm going to hit store as x, right? The variable here is x. So now whenever I plug in, whenever I hit x on the calculator now, it is that number, right? It's negative 2 plus the square root of 7. And then I'll just go and enter this expression on the left and see if I get 15, right? So we take 5 times x squared plus 20 times x, where again x is this number, x is the negative 2 plus the square root of 7. And hopefully I get 15 when I hit enter. And look at that, it is 15. Alright, so this works. So x equals negative 2 plus the square root of 7 works. And then I'll do the same thing with negative 2 minus the square root of 7. Alright, so let's clear this, and let me take negative 2 minus the square root of 7. And it's, this number, negative 4.6 something. I'm going to store this, hit the store button as x. So now every time I hit the x button, it represents that number. And then I'm just going to enter the left side of the equation, wherever there's an x. 5 times x squared plus 20 times x. And again, x here represents negative 2 minus the square root of 7, and hopefully I get 15 again, and I do. So both of these work. Let me get rid of the calculator. So both of these work. Now again, you could have checked that by hand as well. Right, actually plug them in and do it by hand, but calculator is just as valid a check. Right. So both work. Negative 2 plus the square root of 7 and negative 2 minus the square root of 7. Wonderful. But yeah, the same steps though every single time. So I'll get that quadratic term and linear term, with the quadratic term having a coefficient of 1 on its own side. Then complete the square, then solve using the square root property and check your solutions. Right. Next question, same thing. So exercise 3, which is at number 104 from the text. Again, it's already starting off it's almost the way I want it. I'm almost ready to complete the square. I just need to divide everything by 3, right? The quadratic term and linear term are on their own side, but I want the quadratic term to have a coefficient of 1. So I need to divide by 3. Right, so let's write this here, divided by 3. So that gives me, d squared minus, and then 4/3 times d. And then I'm going to leave some space because I can complete the square on these terms now. equals, and then 15 divided by 3 is 5. Alright, now comes the completion of the square. Half of negative 4/3 is negative 2/3. Squared would be positive 4/9. And I do the same thing to the other side, right? Add 4/9. Right. Now, d squared minus 4/3 d plus 4/9 can be expressed as d minus 2/3 squared. And then this side here, 5 is 45/9. Right, 45 divided by 9 is 5, plus 4/9. Get a common denominator, and so this will be 9ths over here, and then 45 plus 4 is 49, which are nice perfect squares. These are nice. So then I can apply that square root property and say that d minus 2/3 must be equal to either 7/3, the square root of 49/9, which would be 7/3, or the opposite of that. D minus 2/3 equals negative 7/3. I'll take this up here. We just solve each of these for d by adding 2/3 to both sides. Alright, so here if I add 2/3, 7/3 plus 2/3 is 9/3, which is 3. We get d equals 3. And here negative 7/3 plus 2/3 would be negative 5/3. And there we go. And check them. And I promise you, if you did everything correctly, they should work out. But I leave it to you to check that these are valid solutions to this equation. D equals 3 and d equals negative 5/3. Great. Alright, example 4, number 106 from the text. So the same steps. First, I want to get the quadratic term and linear term on their own side. So I subtract 8. Right, so we have 3x squared minus 14x equals negative 8. Next, I would like the quadratic term to have a coefficient of 1, so then I can complete the square. So I'm going to divide everything by 3. So that's x squared minus 14/3, right, times x. And then I'm going to leave some space because now I can complete the square, equals, and then over here, negative 8/3, right, divided everything by 3. Alright, now comes the completing the square step. Half of negative 14/3 would be negative 7/3. Squared would be positive 49/9. Right. Negative 7/3 squared would be positive 49/9. And I add this to the other side as well. Add 49/9. Now the left side is a perfect square trinomial. This can be re-expressed as the quantity x minus 7/3 squared. It's the variable plus whatever half that linear coefficient was, that quantity squared. Equals, and then over here, I need a common denominator. Negative 8/3, if I multiply by 3 over 3, is negative 24/9. And then we have plus 49/9. Right? So this is over 9, and then negative 24 plus 49 is positive 25, which is, these are nice perfect squares. This is turning out all right. Now I can apply the square root property, where I got something squared equals to a number. Applying the square root property, x minus 7/3 is equal to the square root of 25/9, which would be 5/3, or the opposite of that, right? Or x minus 7/3 equals negative 5/3. And then I solve each of these by simply adding 7/3 to both sides. Well, for the first one, 5/3 plus 7/3 would be 12/3, which is 4. So x equals 4 is a solution. And again, check it. Make sure it works in the original equation. Then the second one, negative 5/3 plus 7/3 would be positive 2/3. Alright, so x equals 4 or x equals 2/3. And again, please, check them, and they should work. Great. Yeah, same steps every time. Solving a quadratic equation by completing the square. And you might have guessed that, you can do this method for any quadratic equation. Doesn't matter what it looks like. You just have to make sure you get that quadratic term and linear term to one side, and the coefficient of the quadratic term is 1. Alright, so example 5. And this is my last page here. Last two examples. Exercise 108 from the text. Same deal where, the quadratic term and linear term are on their own side. Cool. But the quadratic term, has a coefficient of 3, not 1. So I just divide everything by 3. So now we have q squared minus, 5 divided by 3, 5/3 q. And now I can complete the square because the coefficient on the square term is 1. So I'm going to leave some space for the number I'm going to add to complete the square. And then 9 divided by 3 is 3. All right, now comes the completion of the square. Half of negative 5/3 would be negative 5/6. Right? Remember, when you take half of something, you just multiply the numerator by 1 and the denominator by 2. So it's negative 5/6, but then you square that, which would be 25/36. Right? 25 over 36. That's negative 5/6 squared. And this also gets added, to the other side, plus 25/36. Now the left side is now a perfect square trinomial. Right? This can be expressed as the quantity q minus 5/6 squared equals, and then over here again I'm going to do it, we need a common denominator. Now 3 times 36 is 108, right? 90 plus 18, right? That's 108 divided by 36, that's 3, plus 25/36, and we get this common denominator of 36. Cool. And the numerator would be 108 plus 25, which would be 133. And now I can apply the square root property. Now 133 is not a nice square, right? But by the square root property, the q minus 5/6 is either equal to positive square root of this number. Now that, when I use the quotient property, that would be the square root of 133 divided by, the square root of 36 is 6, right? So the square root of 133 divided by 6. Or the opposite of this, right? Or q minus 5/6 equals, negative square root of 133 divided by 6. Then we solve each equation for q by simply adding 5/6 to both sides. So this first equation, we get q equals 5/6 plus the square root of 133 divided by 6. And you could put these together if you want because they have a common denominator, but I'm going to leave it like this. Or the other equation, adding 5/6, you get positive 5/6 minus the square root of 133 divided by 6. Right. And check them, with a calculator or by hand. By hand would be kind of annoying, but they both should work. Right. Great. Okay. Alright, and then finally, example 6, exercise 110 from the text. So once again, it's starting off with the quadratic term and linear term on their own side. But, the quadratic term doesn't have a coefficient of 1. I would like it to have a coefficient of 1. So I divide everything by 7. That gives me x squared plus, 4/7 times x. And now that the coefficient is 1 on the squared term, I can complete the square over here, so I'm going to leave a little space, equals, and then over here, -3 divided by 7, right? -3/7. Okay. Now comes the completion of the square. Right? So you take half of 4/7, which would be 4/14 or 2/7, and then square that. 2/7 squared would be 4/49. Right, 2/7 squared. And this gets added to the other side as well. Right, 4/49. And on the left side, you got a perfect square trinomial. Right, this can be rewritten as the quantity x plus 2/7 to the second power. Right. Equals, and then over here I need a common denominator to add these together. The first fraction I would just multiply by 7 over 7. So that's -21 over 49. And then plus 4 over 49. And they have a common denominator of 49. Alright, so that's the denominator. Their numerator is added together. -21 plus 4 is -17. Alright. So remember this, we're going to be taking the square root of this number. Remember, the square root of a negative number, we're going to always rewrite as an imaginary. This would be the square root of positive 17/49, so it should be the square root of 17 over 7 times I. Right, don't forget the I, right? I is the square root of -1. This appears whenever you're taking the square root of a negative number. You should automatically think about writing it that way. So, when I apply the square root property here, this x plus 2/7 is either positive square root of 17 divided by 7 times I, or the opposite of that, right? X plus 2/7 equals negative square root of 17 divided by 7 times I. And then over here, to solve x in both of these, we simply subtract 2/7 from both sides. So x equals, -2/7 plus the square root of 17 divided by 7, times I, or x equals -2/7 minus that square root of 17 divided by 7 times I. And you can use, you can do this by hand. You can plug them in for x, these values, and check by hand. Or you can use a calculator that on the TI-84, and I've shown you this before. There's a plus BI mode, a complex mode. Just make sure you're in that mode so you can actually enter imaginary numbers, and then you can check just like I did with any other checking I did in the calculator. But both of those should work. Wonderful. Alright. So that's it. Right? You see that if the solutions have imaginaries or square roots or are just rational numbers, it doesn't matter. No matter what kind of quadratic equation you're given, you should be able to solve it by completing the square, this completing the square method. Right, once more, you set it up so that you have the quadratic term and the linear term on their own side, and that the quadratic term has a coefficient of 1. Then you complete the square and solve using the square root property. And then, of course, check your solutions. Alright, I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to solve a quadratic equation by completing the square on your own. And thank you very much for watching.